This leads us into our permutation formula. If we know we have a permutation, and remember that means order matters. This formula works when repetitions are not allowed. So that's a really important note that you should make. This formula, which we read as NPK, is n factorial over n minus k factorial, where n is the number possible and k is the number we're choosing. So for the example above, with our 5-letter combination code, n was 26 because we had 26 letters to choose from, but k was 5 because we were only choosing 5 of them. So we could figure that out by saying that we have 26 p5, which is 26 factorial over 26 minus 5 factorial, or 26 factorial over 21 factorial, which again we already know is about 7.9 million. But this is the formula. The conditions you must have is that order matters and that repetitions are not allowed. Let's look at an example that uses this formula. Let's say you want to perform a card trick. You're going to select 20 cards at random from a deck of cards. I'm going to tell you that yes, order matters. It does matter for this card trick. And once you draw a card, you set it aside, which means repetitions are not allowed. This is called without replacement. So we are not replacing these cards. Okay. How many different 20 card sets can you get? This is a permutation problem because order matters, and we can use the formula since no repetitions are allowed. We realize that in a standard deck of cards there are 52 cards to choose from. We are choosing 20 of them. So this is 52 p20, which is 52 factorial over 52 minus 20 factorial, 52 factorial over 32 factorial. This is going to be a lot easier to plug into your calculator, so we hit 52, go to the math button, scroll over to probability down to the factorial sign, then divide by 32, and again math button, scroll over to probability and down to the factorial sign. We get 3.065 times 10 to the 32nd. This makes a really important point that we want to use scientific notation here. 10 to the 32nd is a huge number. So you want to make sure you keep this in scientific notation because it's going to be too much of a hassle to write some of these numbers out in standard form. And that does it for permutation. So make sure you understand permutations and that permutations are where order matters. Because next we're going to look at a combination.